Today we will be learning about Boyle's Law. Boyle's Law can be described as P1 V1 equals P2 V2, meaning that pressure 1 times volume 1 equals pressure 2 times volume 2. Boyle's Law is known to have an indirect relationship. This means that if the pressure goes up, the volume will go down, and if the volume goes up, then the pressure will go down. They are indirectly related because if one goes up, the other one goes down, and vice versa. For an example, if I take a household syringe and fill it up with the water in my sink to 5 milliliters, then let's just say it has about 5 kPa of pressure. If I take the same exact syringe that I filled with 5 milliliters of water and release 2 milliliters of the water, then we will be left with 3 milliliters of water inside the syringe now. The pressure must have changed, but we don't know exactly what it is. What do you think? Now, if we have 5 milliliters for the first volume, which would be expressed as V1, and we have 3 milliliters for V2, meaning volume 1 and volume 2, then the pressure for volume 1, let's just say it's pressure 1 equals 5 kPa, just to be easy. And then let's say pressure 2, we don't know, it's X. But we do know the volume of both of these. So next what we can do is set up an equation to find X, which happens to be the pressure of the second syringe, or volume 2. So now it's really simple. All we have to do is apply Boyle's Law to this problem. So if our equation, let's rewrite the equations, P1 V1 equals P2 V2. So let's plug that in. So we got, what we had was a volume of 5 milliliters to start with, so that's P1. So let's put 5 in a bracket, as well as the pressure, which is P1, and that was 5 kPa, so let's write 5 again. And let's equal that to the second pressure, which we do not know, which is X, and the second volume, which is 3 milliliters, or just 3. So what we want to do is multiply these, and I kept it in simpler numbers so we didn't have to use a calculator. So this is 5 times 5 is 25, and this is milliliters, just to let you know, equals, what's 3 times x? That's 3x. That's very simple. This is very simple algebra involved, and we're basically implying that it's at STP, standard temperature and pressure, and we're going to say it's at Kelvins right now if we were dealing with temperature, which we're not because this is Boyle's Law, so we don't even have to worry about that. So we're going to divide the x by 3, and this is going to give us a decimal, so I'm going to have to put it into a calculator, but 25 divided by 3 is, it gives us 8.3. So let's erase this and write our final answer of, you could express it as 8.33, you can really just round it, but I'm going to put the repeating sign, or this can be written as x equals 8.33 repeating. And what is our sign? We don't want naked numbers. It's kPas, because no one likes naked numbers. So that's how you solve a Boyle's Law problem. It's very simple as long as the numbers are kept simple, and it's very easy with a calculator even if the numbers are not simple. You just plug and play with the formula you're given for the individual if you're trying to find pressure or volume, but in this case we're studying pressure 1 times volume 1 equals pressure 2 times volume 2, which happens to be Boyle's Law. Boyle's Law can be applied to submarines. This is because they travel underwater, which involves simultaneously pressure and volume. Now, if something bad were to happen, like depressurization of a certain chamber in the vessel, an entire loads of liters of water could come in and rush in and possibly drown some of the people operating the vessel. So they really have to keep in mind both volume and pressure surrounding their vessel while traveling underwater. Now I have some interesting facts to share with you guys about Boyle's Law. Boyle's Law was discovered not necessarily by Boyle, but by Richard Townley and Henry Power. They discovered basically, or they figured that pressure and volume were first noted to be inversely related by them. But later on, Robert Boyle confirmed their discoveries through his experiments with air, and later basically published them and developed the Boyle's theory, gas theory. But it's really based upon what they discovered. After repeating the experiment several times and using different amounts of mercury, he had found that under controlled conditions, the pressure of a gas is inversely proportional to the volume occupied by it. Now, the French physicist Edmé Mariotte, born 1620 and died 1684, discovered the same law independent of Boyle in 1676, but Boyle had already published it in 1662, so he beat him to the jackpot, basically. Thus, this law is always referred to, or is only sometimes referred to as Mariotte's law, and mostly referred to as Boyle's law. And lastly, the third fact. This law was the first physical law to be expressed in the form of an equation describing the dependence of two variable quantities.